Hi everyone, I'm Dan, the CEO of Causal, and today I'm going to give you a non-technical introduction to causal AI for business intelligence. So you might want to know what's causing something to happen in your business, or what the best actions, interventions, decisions are that you can take. You might want to optimize a process whereby changing one thing has knock-on effects to another, or you might want to make robust predictions in a changing world. For all of these things, you need causal AI. And yet everywhere you look, you see businesses talking about actionable insights with data. But you can only really make actionable insights with data if your statistics, machine learning, AI understands real-world processes and operates as if it was in the real world. So despite the wide use of the term actionable insights, only causal AI can do this because it essentially creates a causal digital twin of the real-world process. So it means that when it makes a recommendation, it actually applies and works in the real world. And most business questions are causal in nature. They're about what decision, action, or intervention you want to take to achieve a desired outcome. It's not just about predicting an outcome, it's about shaping it. That's really what we want to do. And across different industries, there are so many questions that are causal. What is the impact of a customer's viewing and buying behavior on purchase decisions? Will offering a discount or how much of a discount will reduce customer churn? How can we optimize our supply chain? What's the root cause of a fault in a process or a set of machinery? And what I'm going to show you is that using dashboards or standard AI can mislead you when it comes to business intelligence questions. But causal AI gets it right and offers massive business value. So let's have a look at standard AI first. Well, standard AI is designed only for forecasting or prediction. So it can only predict outcomes, it cannot shape them. And it predicts outcomes through correlations. It works a little bit like a data blender, where the blender here could be anything you like, a neural network or anything. But you toss the data in, you hit blend, and out comes your prediction no matter the mix. And this last bit is the important bit. It's no matter the mix. The standard AI doesn't care how it gets there. It creates its own world model that might not map onto the real world. Because standard AI is all about the outcome, the end result, without caring how it got there. But just because two things seem to be related doesn't mean that one thing caused the other. It's a simple truth that we all know, but standard AI gets confused over this, leading it to completely wrong decisions and optimizations that cause businesses money and trust. Causal AI gets it smart. It carefully can model cause and effect relationships between all of the variables in your data where there's a possible cause and effect. And this is much smarter, even from just a common sense perspective. It's also essential for AI that you can trust, because it's transparent in what it's doing. You can see exactly what it's doing, how and why. So it's accountable AI. And unique to causal AI, the processes in the causal models map to the real world processes. So it operates as if it was in the real world. And being able to map your model from a real world process to your AI and the other way is a requirement for data-driven decision making. But standard AI misses this completely. Let's have a look at a kind of silly example where two things are correlated. In this case, it's just by chance. Here we can see that in the US, cheese consumption and strangulation by bed sheets are tightly correlated, but I think we can all agree that there's no cause and effect here. But let's take our standard AI model and use this to predict bedsheet deaths from cheese consumption. And if we only focus on the forecasting, the predicted outcome alone, this is fine. We can predict one line from another. But most of the time we don't want that. We want actionable insights from our AI. We want to know what are the best decisions that we can make. So let's ask what would happen if we intervened and increased cheese consumption or decreased it. Well, the standard AI model would tell you that strangulation by bed sheets would increase if you increased cheese consumption. So is it time to ban cheese? Well, clearly this is nonsense, and it's a silly example, but actually this illustrates to you why you can't use standard AI, which is based on predictions, for decision making when it does come to real data that matters to you. But we do need to use AI as a tool to help us make decisions. It needs to tell us what would happen if we took action and made a change. It needs to tell us why and what if, and only causal AI can do this. Now let's have a look at another example, another toy fun example, where there's a correlation, but no cause and effect, but a correlation isn't by chance this time. So the common example here is that, ice cream consumption is positively correlated with shark attacks. In that the more ice cream that's consumed, the more shark attacks there are. Now, this is due to something called a confounder. And a confounder is something that is a common cause of both the outcome and the cause that you're interested in. Here, this is sunshine. Now, there are lots of different motifs in these causal structures I can talk about and different things we should be doing with them, all of which are taken care of in CausaDB. There are colliders, there are mediators as well. I'm not going to talk about those today because I want to keep this straightforward, but those will be the subject of future videos. So here, why is it a confounder sun? Well, it might be that higher temperature or a sunnier day means that people are having more ice cream, but also they're more likely to be on the beach going in the water. Right? So this is something we need to consider, and it happens all the time. You get these in the real world data, in your business data. Here's a really simplified example. We want to look at the effect of giving a discount on customer churn. We might want to know how much of a discount to make so we can do a cost-benefit analysis. But here, bugs encountered, this might be a software package, by the way, and the bugs encountered might be a confounder, because it might be that if someone's using this software, the more bugs that they encounter, the more likely they are to stop using it. But it might also be that the company is giving discounts conditional on the bugs encountered. So you're more likely to get a discount if you've reported a bug. So this is a confounder. And what happens if we don't properly model this and take it into account? Well, what it says is that if you give a discount, there's a higher chance of churning customers. So it looks like a discount is bad. And if you had a standard AI model of this, the data scientist might dress it up with some storytelling about, well, maybe it's because a discount seems to cheapen the software and so people are leaving. But if you actually properly model bugs encountered as a confounder here, this result flips, right? So it's not just about a change in the estimate. The result flips, and now you found that giving a discount is a good thing. You can actually model as complicated a real-world process as you like with these models. And let's just add one more variable in here, which is length of use, just to build this up. And this is what happens in the real world. But actually, there are 4 different causal pathways here. So a causal pathway is a forward path, the arrow is pointing all the way forwards from the thing that you're interested in. We call it the exposure, but the cause of interest, all the way to the outcome. So here's the first one. So length of use, the longer you use the software, the more likely you are to experience bugs. And experiencing bugs might make people more likely to churn. But the longer you use it, the more likely you might want to keep using it. And then there are other pathways too that I won't go into detail, but I'm sure you can work out these pathways. These are all forward causal pathways, and you can see why we might need to consider these. If we're making a decision, we need to know if we change something here, what are the knock-on effects to make it change the result, okay? And it might be even an optimization. Again, we change this and tune it up. What are the knock-on effects? In standard AI, this isn't modeled, right? It's just you just throw everything into this blender and get customer churn out. And so if you change length of use, it isn't changing everything else. If you change discount, it's not changing everything else. This essentially is standard AI's understanding of how the real world works. But causal AI's understanding twins the real world. Okay, you can put these arrows in and relax the assumptions of standard AI so that it can learn these relationships. And let's have a look at an example here of optimization, because standard AI is often used for decision making because it's the only way to make proper decisions, but really you need it for optimization and some prediction problems too. Here we have an app for smart building optimization using our flagship platform CausaDB. And here we're setting a target building temperature, and we know the size of the building, maybe it's a supermarket and so on, and we're optimizing their HVAC systems. So the settings for their air conditioning to pre-cool and preheat, maybe the settings for the fridge freezers and so on, and we have to consider the outdoor temperature when people are coming into the building and so on. The key here is that there are knock-on effects from any tunings you do. What the outdoor temperature is should affect what you set maybe the air conditioning at. but what you set the air conditioning at certain times might affect what you set the fridge freezers to. Causal AI understands these relationships, and if it tunes something in the model, that will impact it in the same way of tuning it in the real world. This is not the case for standard AI. So we fit like-for-like models of standard AI and causal AI. Here, standard AI is in purple, causal AI is in green. And what you can see is that causal AI keeps much closer to the target temperature than standard AI. We're optimizing for two things here, by the way, for the temperature to be constant at what we want it to be, but also minimizing energy expenditure. We don't want to be preheating and pre-cooling when we don't need to. And that's a reason. This is one of the reasons that standard AI gets it wrong. It doesn't understand the cause and effect relationships and the knock-on effects. And so now you can do some calculations based on the building size, see what the wastage is in terms of energy and the cost of that wasting that energy. And you can see that causal AI massively improves on standard AI. It saves a lot of money. So we have a flagship platform, CausaDB, which is a powerful causal AI platform. It's easy to use and it helps you to rapidly build and deploy causal AI models and either work with us to build some standalone decision apps or integrate the models into your own apps and wider systems. It's all cloud hosted, so we take care of all the infrastructure and compute, making it immediately deployable and scalable all the way from SME to enterprise. So follow me for more causal AI content coming up and visit our website at causa.tech for more about CausaDB. And I'll see you all next time.